This video is going to show you how to use the integrating factor approach to solve a differential equation. In this example, we are given that x to the power 3 times dy over dx plus 4x squared y equals to the right-hand side e to the power of 8x divided by x. With the given condition, y is equal to e to the power 8 divided by 8 when x equals 1. We are going to solve this differential equation, which means we would like to find an expression of y in terms of x which satisfies the above differential equation. In order to solve this differential equation by using the integrating factor approach, the first thing we need to do that is to make sure that the left-hand side has two and only two terms, where the first term must be dy over dx with the coefficient 1, and then the second term would be corresponding to the term for the small letter y. So from this expression, if we have to make sure that the coefficient of dy over dx equals to 1, we can then try to have the division of x to the power 3 for all three terms. So that the first term becomes dy over dx, and then the second term becomes 4x squared divided by x to the power 3, which would be equals to 4 over x, and then times y. For the right-hand side, the fraction divided by x to the power 3, which means the result will be e to the power of 8x divided by x to the power 4. This step is very important as we have to make sure that the left-hand side has this particular format and we have to identify the coefficient of y. So in this case, the corresponding coefficient of y, that will be 4 over x. And then we will be able to find out the integrating factor for solving this differential equation. Integrating factor is defined to be e to the power of a particular indefinite integral, where the expression in this integral would be corresponding to the coefficient of y in the above differential equation, which means this integrating factor would be defined as e to the power of this, and then we are going to input 4 over x inside this particular integral. Inside this integral, as we can consider 4 to be the coefficient of 1 over x, then integrating 1 over x, we will be able to have natural log x. During the process of finding the integrating factor, it is not compulsory to write down the arbitrary constant here. And then in order to simplify this expression, first of all, we can see that 4 is the coefficient of natural log x. And then we will be able to apply one of the laws of logarithm such that the coefficient of natural log x can be rearranged to be the power of x inside the natural logarithm. As e to the power x and natural log x are the inverse functions of each other, then we can consider the cancellation of e and natural log, so that the result will be x to the power 4. Once we successfully find out the expression of the integrating factor, we will be able to multiply this integrating factor into each term of the original differential equation, so that we will have x to the power 4 times dy over dx, and then 4 over x times x to the power 4, we will be able to have 4x to the power 3. Similarly, for the right-hand side, e to the power of 8x divided by x to the power 4, and then multiplied with another x to the power 4, that will be equals to e to the power of 8x. And then we will be able to observe a special pattern on the left-hand side. We will be able to find two pairs of information that will be related to a function and its corresponding derivative. Say, for example, we can consider y to be a particular function, and then dy over dx would be its corresponding derivative. In addition, we can see that x to the power 4 would be another function, where its corresponding derivative would be 4x to the power 3. If we consider y to be a function fx, consider x to the power 4 would be another function gx, we will be able to see that the left-hand side structure looks like the product rule. And according to the product rule, this is based on the derivative of a product of two functions f and g, which means on the left-hand side, we will be able to rewrite as d over dx, and then we arrange the bracket. Inside this bracket, that should be the product of f and g. That will be y times x to the power 4. And the right-hand side is unchanged. Now we have the derivative of yx to the power 4 equals to e to the power of 8x, which means when we are going to consider yx to the power 4, it should be equals to the indefinite integral of e to the power of 8x. In order to integrate the right-hand side, we will be able to consider the coefficient of x, which will be 8, and then we are going to include 1 over 8 in front of e to the power of 8x. And of course, with an arbitrary constant. At this moment, if we wish to find the value of this arbitrary constant, we can try to consider the given condition x equals to 1 and then y equals to e to the power 8 over 8. Then on the left-hand side, we will be able to have e to the power 8 divided by 8 and then times 1 to the power 4, such that the right-hand side, it will becomes 1 over 8 e to the power of 8 times 1 and then plus c, such that the left-hand side will be e to the power 8 divided by 8, which will be equals to the first term on the right-hand side. Then we will be able to see that the value of c, that will be 0. Then the expression becomes y times x to the power 4 equals to 1 over 8 times e to the power of 8x plus 0. And then divided by x to the power 4 for both sides, we will be able to get this conclusion, e to the power of 8x divided by 8x to the power 4.